In this problem, we need to solve the system of linear inequation. Let's begin. Here we will consider the first linear inequation. We have 3x minus 6 greater than or equals to 0. We'll transpose 6 from the left hand side to the right hand side to get 3x greater than or equals to 6. Now we want to make the coefficient of x on the left hand side 1. To do that, all we have to do is divide both sides of the linear inequality by 3. Now in doing so, 3 being a positive number, there is no change that's going to happen to the sign of the inequality, meaning we'll use the property, let's say if a is greater than or equals to b, and we have another number c, which is a positive number, that means greater than 0, then if we multiply a with c and b with c, then in that case, AC will be greater than or equals to BC. So there will be no change in the sign of the inequality. Right. So the 3 and 3 gets cancelled out, and 3 times 2 is 6. So that leaves us with x greater than or equals to 2. So this is one solution that we have obtained by solving the first linear inequality. Now let's come to the second linear inequality. So here we have 4x minus 10 is less than or equals to 6. Transposing the 10 from the left hand side to the right hand side, so that's going to give us 4x is less than or equals to 10 plus 6. So 4x is less than or equals to 16. Similarly, what we'll do, we'll try to make the coefficient of x 1. To do that, all we have to do is divide both sides with positive 4. So on doing so, the sign of the inequality is still not going to change. That means if a is less than or equals to b and c is a positive number, then ac was still going to be less than or equals to bc. Right. So the 4 and 4 gets cancelled, and 4 times 4 is 16. So this gives us another solution, which is x is less than or equals to 4. So here we have two solutions, x greater than equals to 2 and x less than equals to 4. Now we'll have to find a common solution that satisfies both the two linear inequalities. To do that, all we have to do is sketch a number line. On this number line, we're going to consider the point 2 and 4. Right. From the first linear inequality, we have x greater than or equals to 2. So that means we have to consider all the values of x, including 2, and values of x greater than 2. That means the solution is going to lie to the right hand side of x equals to 2. And the second inequality gives us x less than equals to 4. So that means we'll have to consider all the values of x which is less than 4. That means lying to the left of x equals to 4, including 4, because we have a less than or equal to sign. Now the common solution will be this particular region, which is between 2 and 4. So here we have a common region. That means our solution will be x is greater than or equals to 2, or and, not or, it's going to be and x is less than or equals to 4. So this is the combined solution. If we want to write the solution in the interval form, so that will be 2, 4. So here 2 and 4 are both part of the solution, so we are going to use a closed interval. Right. So this is a solution which is going to satisfy the system of linear inequality. In a sense, if we consider any number between 2 and 4, this is going to satisfy the linear inequality. To do that, we can check by considering a number. Let's say x is equals to 3. So 3 is a number which lies in the interval 2 and 4. So if we substitute this into our linear inequality, then we'll have 3 times 3, so that's 9. 9 minus 6 greater than or equals to 0, and 9 minus 6 is 3. 3 is greater than 0, so that's a true statement. For the second one, we have 4 times x minus 10, so that's 4 times 3 will be 12, so we have 12 minus 10 less than or equals to 6, and 12 minus 10 is 2, and 2 is definitely less than or equals to 6. We can now check with some other values. Let's say x equals to 5. So x equals to 5, it's not lying in the solution set. So if we use this value, then we have 3 times 5. So that's 15 minus 6 greater than or equals to 0. So this will be 9 greater than equals to 0. So this is true for the first linear inequality. But if we consider the second linear inequality, so we have 4 times 5. So 4 times 5 is 20. So 20 minus 10 is less than or equals to 6. 20 minus 10 is 10. So 10 is actually not less than or equals to 6. So if we consider x equals to 5, then this is going to satisfy the first linear inequality, but not the second inequality, which means that this is not a solution that solves both the two linear inequality. So our only possible solution will be the solution lying between the interval 2 and 4, where both 2 and 4 are included.